Buddy, I want to tell you why it makes sense that all fractions either have a decimal that repeats or terminates. And I'm going to use an example that kind of illustrates how it works in general. And I asked you to do this as part of your work in small groups. I asked if 3/7 was a terminator or a repeater. Or before we even start, we might wonder maybe it's the kind of decimal that goes on and on and on and on without ever repeating. So my claim is that all fractions are either, that should say are either terminators or repeaters. In other words, I'm claiming that you cannot have a fraction that has a decimal name that goes on and on and on and on without ever ending or repeating. All right, let's see why. So one of the ways we turn a fraction into a decimal is we do the long division. So 3 divided by 7 looks like this, 3 divided by 7. And notice that whenever you do long division, right, you're always wondering how many times this number goes into what's over here. So, and I'm thinking of that as 30 right now. So 7 goes into 30 4 times. 4 7s is 28. And then I can do the subtraction and bring down another 0. I have all the zeros I want here. And I'm going to be asking how many times does 7 go into 20? And it's twice. 2 times 7 is 14, and I get a remainder of 6 here. So I just want to point out that what I'm calling these things here are the remainders. So I just got a remainder of 6, and I bring down another 0, and I say how many times does 7 go into 60? Let's see. 7 times 8 is 54. 56. I had to think about that for a second. And I get 4 left. So that's the next remainder. Okay, so hold on a second. Before we go any farther, when dividing like this, what are the possible remainders? So far we've gotten a 2, we've gotten a 4, we've gotten a 6. You might ask yourself, is it possible to get like a 10 as a remainder? And you'll see it's not if this is a 7 here. Remainders have to be less than 7. If you got something 7 or bigger, then you should have gone in one more time up here, right? So the only possible remainders at the onset are you could get 0, in which case you have a terminator. Or you could get 1, 2, 3, 4, 5, or 6. If 7 is the denominator of your fraction. So notice the 7 is the denominator of my fraction. The possible remainders are only those. And so far we've seen this one, we've seen this one, and we've seen this one. And if we get 0 as a remainder, then the decimal name ends. So let's just keep going, see what happens. So I'll bring this down, 0. Let's see, 5. 5 times 7 is 35. And we get a remainder of 5. That was this one. And I'll bring down a 0. Oh, 7 times 7 is 49. 7 times 7 is 49. And I get a remainder of 1. So I got this one. And I'll bring down a 0. 7 goes in there once. 1 times 7 is 7. And I get 3. That was that one. And I bring down a 0. And now how many times does 7 go into 30? 7 goes into 34 times, just like it did at the start. 4 times 7 is 28. And if I do the subtraction, I get 2, just like I got before. So it's going to go into 22 times. You notice I'm starting to repeat here. So the point is that as soon as you see a remainder you've had before, then the thing starts to repeat. As soon as you've seen a remainder you've seen before, the decimal repeats. So if you're given a decimal, any decimal at all, say like 15 over 21, you know that this guy either has to terminate or repeat at or before 21 iterations of the long division. This one actually repeats long before that. But it has to, because at the onset, just looking at this, the only possible remainders that you could get are 0 through 20. And the worst that could happen is you could use them all possible remainders, and run out. Then you've got to get one you've gotten before, or you've got to get 0. So the denominator of a fraction gives you a limit, if you will, on how long it will be before that decimal name repeats or terminates. We are going to do one more example just to show you a couple other things. So first of all, I want to do the example of 1/5. Now I know that 1/5 has a decimal name that terminates or repeats within 5 iterations of the long division procedure, because the only possible remainders if I take 1 divided by 5 are 0, 1, 2, 3, or 4. So I'm just going to start doing it, see what happens. So 5 goes into 10 twice. 2 times 5 is 10. And notice, oh, I got 0. If I get 0 as a remainder, I'm done. And the thing terminates. Okay? So notice that. Let's now look at the number, how about 1/3, and see what happens. So I know the only possible remainders when I do this one are 0, 1, and 2. So the longest I could ever do long division before it started either repeating or terminating would be to go 2 rounds. So let's see what that looks like. 1 divided by 3. This goes in here 3. 3 times 3 is 9. I got a remainder of 1. See that? Bring down a 0. 3 goes into here. 3 times again. 3 times 3 is 9. I get the remainder I had before. The thing is repeating. So one more time, the point is this. All fractions have decimal names that either terminate or repeat. You cannot have a fraction with a decimal name that keeps on going and going and going without ever finishing or repeating. The denominator of the fraction limits how long it will be before you get termination or repeating.